Hey all, welcome to Homeschool. Hope everybody are doing good and welcome back to Class 11 Physics series. Today I am going to teach you the basic mathematic tools that is helpful to understand Class 11 and 12 Physics. So usually these mathematical tools will help us in solving physics problems easily. Few concepts involve these mathematical tools. So without having an idea about these tools, if you study them, you don't understand anything. For example, instantaneous velocity and instantaneous acceleration that we studied in motion in straight line chapter. To solve the problems of those concepts, this integration and differentiation is must. So these mathematical tools makes our life more easier, especially in case of physics. And we do use them in chemistry also, but its use is very much limited in chemistry. But everywhere we use this integration and differentiation in physics. There are so many derivations that involve these mathematical tools. So let us understand few basic aspects of this integration and differentiation. And also trigonometric functions. Trigonometry is the one which you have already studied in your basic classes. So I'm not going to trigonometry, but trigonometry is also very important to understand certain concepts of physics, right? And I have already covered 3 chapters in class 11 physics. Video links are provided in the description. You can go and check it out if you have not yet watched. And coming back to the topic. First, let us understand why we use differentiation and integration. In what situations we can use differentiation and integration? What actually we mean by those tools? So, coming to differentiation. So, the word itself says differentiate. So, differentiation, right? Okay. Differentiate in the sense what? To separate, right? So differentiate these things, differentiate those things. What do you mean by this? It means that we have to separate. Okay, we have to break into smaller and smaller units. That's what is the another meaning of differentiation. For example, in your early ages, you might have played these puzzles, right? So you will have this kind of stuffs where you need to arrange and give a particular shape or to give a particular picture, right? So imagine there are so many puzzles arranged and it's a picture of something. And if I break this into smaller and smaller pieces, this is what we can call it as differentiation. Normally, it's like a bigger puzzle. The blocks were neatly arranged and that one I am breaking into smaller and smaller pieces, right? So this is what we do in differentiation, right? So here a big function, a function which is big, a big mathematical function, okay? This function we are breaking into small functions, right? It can be any function. It can be polynomial function, it can be algebraic function, or it can be trigonometric function, logarithmic function, any function. A bigger function, normally we are breaking into smaller function. Okay, so to do this, we use a tool called differentiation, right? So using differentiation, what we are doing? We are doing a bigger function. I mean, we are actually breaking a bigger function into smaller function. Just like a arranged puzzle, how you break into smaller and smaller pieces, the same way a bigger mathematical function can be broken into smaller and smaller pieces. Okay, so for that, to do this, we use a tool differentiation. So this is a general basic idea. And what is integration? So integration is just opposite to this. Integration is an opposite tool for differentiation. In integration, what we do is too many small functions we add to make a big function. Okay, so many small functions are joined together to give a big function, right? So integration and differentiation are two opposite tools actually, right? So even the formulas that you learn is quite opposite. So in differentiation, big function, broken down into smaller functions, and in integration, small functions you can join and make it a big function. So this is what the meaning of differentiation and integration in a normal language. Okay, but in mathematical language it is very much different. The way you express them and what are the formulas, what are the rules, everything we have to study. So now I gave you a basic idea. Now let us go to their mathematical meaning, how we can express them, how we can write them, right? So there are certain rules, all of them we will learn. First, let us talk about differentiation. Okay, so first we will discuss all the formulas of differentiation. Later we will go for integration. Usually differentiation is expressed something like this. Okay, so this is the way of representing differentiation. See, we write it as dy by dx. Okay, so here y and x are variables. So they are variables and they are related. They are actually related with each other. Through a function. Okay, and here one thing you must know, x, whatever you have written down in the denominator, that is x is independent variable. It is independent variable always. Okay, and whereas y is dependent variable. Okay, so remember x is always some independent variable. Both are variable but both are related to one another through a function. Okay, so we normally write like y is equal to f of x. So this is what the function, a small function, right? So with differentiation, in terms of differentiation, we can write this as dy by dx. Okay, so what do you mean by y is equal to f of x? You can represent this as dy by dx. Okay, so where y and x both are variables, both are related with each other through some function. Okay, so this is the way we represent differentiation, right? And there are certain formulas that you have to understand in differentiation. Let us go to the formulas. See guys, first and foremost, the first rule or the first basic formula is power rule. Power rule. So when you have some polynomial function, usually, for example, y is equal to u to the power n, right? You want to differentiate dy by dx. That means you are what is your y? U to the power n. That means you are differentiating u to the power n with respect to x. So what do you mean by dy by dx? You are actually differentiating y with respect to x. Okay, it is just like rate of change of something. Okay, so you are differentiating y with respect to x. Okay, so what is y here? Something to the power n. So when you have this, the formula here is n comes outside, it becomes u to the power n minus 1 you have to do into du by dx. Okay, so this is what the formula we will use. Whenever you have to differentiate something to the power n, then n, write it like this, u, n minus 1 you have to do into du by dx. Okay, fine. Say one example here. Imagine if y is equal to, you have x to the power n. Okay, so then how do you differentiate? Dy by dx is equal to, so what is y? X to the power 1. You have to differentiate x to the power n with respect to x only. Okay, so how do you write? Anything to the power n when you have n comes outside, x n minus 1 into dx by dx, right? So usually dx by dx value is 1 only, right? So here your formula is n x to the power n minus 1 only, because dx by dx is always 1. Okay, fine. And let me give one example here. So how do we use this particular formulas? I mean this particular rule. You have y is equal to x cube. You have to differentiate. So how do you differentiate this? Dx cube by dx is equal to, what is your n? N is 3, right? So n you will write, what is the format? N into x to the power n minus 1. So what is n? 3 into x to the power 3 minus 1 into dx by dx. X only, dx by dx. Okay, so what is the answer here? 3x square is the answer. Dx by dx is 1. Okay, so 3x square is the answer. So this is how we use this power rule. And another example, example number 2. You have y is equal to 1 by x. So how do you differentiate? So this 1 by x, you can write it as x to the power minus 1. So differentiation of x to the power minus 1 by dx is equal to, what is the power? Minus 1. Outside you write minus 1 into x to the power minus 1 minus 1, n minus 1. So n is what? Minus 1. So minus 1 into dx by dx. So you will get minus 1 x to the power minus 2. Right? So this is your answer. So this one I can also write it as minus 1 by x square. Right? So x to the power minus 2. It means it's an inverse square. Right? So I can write this as minus 1 by x square. So differentiation of 1 by x is always minus 1 by x square. Right? So this is where in different situations we can use this power rule. And coming to next particular formula. Differentiation of constant is always equal to the 0. Okay. Imagine if y is equal to a is some constant. Right. So here dy by dx is equal to, what is y? dA, that is some constant. Right. So its value is always equal to 0. For example I'll show. Imagine y value is equal to 5. You have to differentiate 5. So differentiation of 5 with respect to x is always equal to 0. Okay. So this is how always keep in a mind that differentiation of any constant is always equal to 0. Okay. So, and remember, this is a very basic thing one must understand, that is the power rule. And now let us go for exponential rule and logarithmic rule. So now exponential rule. That means if you have an exponential function, then what are the formulas we have to use? For example, okay, so formula number 1. If you have y is equal to e power x, then dy by dx, that is d of e to the power x by dx is equal to e to the power x only. Okay, so differentiation of e to the power x is always e to the power x itself. So when you differentiate this with respect to x, then it is equal to e to the power x. Okay, and now the second one. If you have y is equal to e to the power y, then differentiation of e to the power y with respect to x is equal to e to the power y into dy by dx. Okay, so when you have to differentiate e to the power y with respect to x, then e to the power y into dy by dx. Okay, so these are the two important formulas that you need to remember when you are differentiating exponents. Okay, fine. And coming to log rule. log rule. So how to differentiate logarithmic functions? Okay, say if y is equal to ln x, so ln is nothing but natural logarithm which is represented as ln. Okay, so if y is equal to ln x, then differentiation of ln x with respect to x is always 1 by x. Okay, so differentiation of ln x is equal to 1 by x. And now if you have to differentiate ln y, okay, with respect to x, that is dx, then the formula is 1 by y into dy by dx. Okay, so these are few more important formulas that you need to remember. So you will have their use in the later chapters. Okay, fine. And now let us understand the differentiation of trigonometric functions. So coming to derivatives of trigonometric function, derivatives or differentiation is one and the same. Okay, so if you have to differentiate sine x with respect to x, okay, so d of sine x by dx is always equal to cos x. Okay, so cos x is your answer. Differentiation of sine x is cos x. Okay, and similarly differentiation of cos x by dx is equal to minus sine x. Okay, so in this case it is minus sine x. This is a formula. Differentiation of cos x is always equal to minus sine x. And coming to differentiation of tan x with respect to x is sec square x. Okay, and differentiation of sec x with respect to x is equal to sec x into tan x. Sec x into tan x. Okay, and coming to differentiation of cot x with respect to x is equal to minus cosec square x. And differentiation of cosec x by dx is equal to minus cosec x into cot x. Okay, so these are some derivatives of trigonometric functions you have to remember. Along with that, the basic idea on trigonometry, like standard values of trigonometric functions. Sine 0 is how much, sine 90 is how much, sine 45, sine 60, like that, cos 0, cos 90, cos 45, you know, all these values I think you must have studied in your basic classes, right? So now I am talking about the derivatives of trigonometric function. So if you differentiate sin x, the value is cos x, and differentiation of cos x is minus sin x, differentiation of tan x is sec square x, differentiation of sec x is sec x into tan x, differentiation of cot x is minus cosec square x, differentiation of cosec x is minus cosec x into cot x. Okay, so these are some formulas that you need to remember. Fine. And coming to addition rule, say you have a particular equation, y is equal to this much, and you have to differentiate. So what is the value of dy by dx? Okay, so dy by dx, you know, you have to differentiate every single term. Okay, so here differentiation of x by dx plus x to the power 4, differentiation of x to the power 4 with respect to dx plus differentiation of 1 by x by dx plus differentiation of 2 root x by dx plus differentiation of cos x by dx minus differentiation of 3e to the power x with respect to dx. You know, like this, when you have this particular equation where you have addition and subtraction terms, so you have to apply differentiation for each and every term. So we have learned the formulas. You just have to apply the formulas and solve this equation, right? So how much is dy by dx? So differentiation of dx by dx is 1 plus, and it is a power rule you have to apply, right? So here what is the value? 4 into x to the power n minus 1, that is 4 minus 1. That means 4x cube, right? So differentiation of this term is 4x cube plus differentiation of 1 by x. 1 by x means what, guys? You can write it as x minus 1. So that is minus 1 into minus 1 minus 1. That is minus 2. So how do we write this? We can write it as minus 1 by x square, right? And then plus differentiation of 2 into root x. 2 you bring it outside and differentiate root x. Okay, so root x, how do you write root x? Root x you can write it as x to the power 1 by 2 with respect to x. You have to differentiate this. Okay, so how do you differentiate this? You will write it as 2 into 1 by 2, right? Into x to the power n is 1 by 2 minus 1, right? So you will have minus 1 by 2. So how do you write this minus 1 by 2, x to the power minus 1 by 2? You can actually write it as 1 by root x, right? So the differentiation of this value is 2 into 1 by 2 into 1 by root x plus differentiation of cos x. Formula we have seen, differentiation of cos x is minus sin x. So minus sin x, right? Minus differentiation of 3 into e to the power x. So 3 outside, differentiation of e to the power x is e to the power x only, right? So this is what the answer you will get. Here 2 gets cancelled. So ultimately what is your equation turning to be? 1 plus 4x cube minus 1 by x square, right? Plus 1 by root x minus sin x minus 3 e to the power x. So dy by dx answer is this much, right? So this is how you have to use differentiation for such equation. This is what is helpful for our physics. This is how we apply differentiation in case of physics. Okay, so we have seen various formulas of differentiation, and now let us understand where exactly we can use this differentiation. See guys, this differentiation is used in many concepts of physics. See, one such example is understanding instantaneous velocity and instantaneous acceleration that we studied in motion in straight line. See, we can easily define instantaneous velocity and acceleration with the help of differentiation, and we can easily solve the problems of those concepts with the help of differentiation. And let's see how it can be done. And let's understand instantaneous velocity as well as acceleration in terms of differentiation. Okay, so for that, just observe this particular plot where I have a graph of y versus x. Okay, so imagine I got a curve something like this, right? So I didn't get a straight line, I got a curve like this. When we have to find a slope at a particular point, at a particular point we draw a tangent, isn't it? So let me consider these are the 2 points of a curve, right? And you know what, with respect to these points, this is what the difference in x, let me call this as delta x. I'll draw a small triangle where slope of this triangle. So how do you find the slope of this triangle? This difference, this is a small difference delta y, and this is a small difference delta x. Okay, so slope is equal to delta y by delta x. Okay, so this is really a very, very small difference, right? So delta y and a small difference delta x. So slope is always equal to delta y divided by delta x, which is nothing but tan theta, right? You see this, and this particular thing can also be represented as dy by dx. This small difference in y and small difference in x Okay, so delta means large difference, whereas the moment you write small d, it means that small difference. Okay, so this particular concept we can express in the form of differentiation, right? So we can write the slope as dy by dx. Okay, so like this, let me connect this to instantaneous velocity, right? So what is instantaneous velocity? It is nothing but velocity at an instant of time. Velocity at an instant of time is called instantaneous velocity, right? Say for example, when you have a xt graph, let me consider xt graph, right? So that is position time graph. So this is a position and the horizontal axis is your time. And when you have a straight line, at an instant, if you want to find the velocity, slope of this line will give you value for velocity. All that we have discussed in the video on graphs, right? Okay, so how do you find the slope of this point? At this point, if you want to find out the slope, it is equal to the average velocity only, right? So when you have a straight line, instantaneous velocity is equal to average velocity. Okay, so slope is same at any point and slope is common between any 2 points, right? So whereas if you get a curve something like this, okay, when your velocity is constantly changing, when you have a changing velocity, if at this particular time, at this time I need to find the velocity, then what do? At this point you will draw a tangent, right? And the slope of this tangent will give you instantaneous velocity. And you see here, it is a very, very small change in distance. This is a very small change in distance and this is a very small change in time, right? So here slope is nothing but your velocity, instantaneous velocity. Okay, instantaneous velocity is equal to what we can write, delta x by delta t we will write. Whereas here we have to apply the limits, right? So providing limits delta t tends to 0. Okay, so when delta t almost, this difference almost when it approaches to 0, then delta x by delta t will be the value of slope, and the value of slope is nothing but the instantaneous velocity, right? Say this one we can also write it as dx by dt, right? Say we can also define our instantaneous velocity. Okay, so instantaneous velocity can be defined as dx by dt. Okay, so small change in x, that is in distance, by small change in time. Okay, so instantaneous velocity can be defined in terms of differentiation, right? So instantaneous velocity is nothing but dx by dt. So if you have a particular position given in a question, you can differentiate that, you will get the value of instantaneous velocity. Okay, so when we solve a problem, you would understand better actually, right? And how do you find the instantaneous acceleration? Similarly, you can also find instantaneous acceleration. It can also be defined in terms of differentiation, right? So how do we define instantaneous acceleration? It is dv by dt. Okay, so or d of, what is v? V is nothing but dx by dt, right? Dx by dt. See, this is first derivative and this thing once again I am differentiating. So second derivative I am doing. Okay, so this will be d square x by dt square. Okay, so acceleration can also be defined this way. Okay, in terms of velocity, if you want to define, it is dv by dt, right? And in terms of position, if you want to define acceleration, it is d square x by dt square, and this is called as second derivative. Okay, so this was the first derivative, right? And this factor 2 times we have differentiated. So we call this as second derivative. Okay, so acceleration in terms of differentiation, you can define it this way or you can define it this way. So these are the different formulas. Actually, we will use it for solving problems. Okay, so this is where the differentiation is helpful. So whenever you want to find a very small difference, a very small slope, if you want to find a particular distance or velocity at a point, at an instant of time, then differentiation comes into picture. Okay, so it makes our life more easier to solve the problems on instantaneous velocity as well as instantaneous acceleration. Okay, so now let us look at one problem where with the help of differentiation we can solve it. See guys, look at this question. The position of an object moving along x-axis is given by x is equal to a plus bt square. Okay, say the position is given by a particular equation, that is x is equal to a plus bt square, where a is equal to 8.5 meter, b is equal to 2.5 meter per second square, and t is measured in seconds. What is its velocity at t is equal to 0 seconds and t is equal to 2 seconds? See, they are asking velocity at this time instant and also velocity at this time instant. So here only we can understand that they are asking instantaneous velocity at t is equal to 0 seconds and instantaneous velocity at t is equal to 2 seconds. Okay, so at this time what is the velocity? At this time what is the velocity they are asking? Okay, so instantaneous velocity they are asking, and position of an object is given by this equation. X means what? Position. Okay, x is equal to this one. So how do you do? So we know instantaneous velocity is equal to dx by dt. It can be represented as dx by dt with the help of differentiation. Okay, so what is x here? You have to differentiate. What is x? X is this equation. Differentiation of a plus bt square you have to do with respect to time. So differentiate. Differentiation of a by dt plus differentiation of bt square by dt, addition, right? Differentiation of this term and differentiation of this term. So differentiation of a is a constant, you see, it's a constant. So differentiation of constant is always 0, right? And differentiation of bt square, and this b comes outside. So differentiation of t square by dt. Okay, so what is differentiation of t square by dt? We have learned a formula, right? Differentiation of x square by dx is what? 2 into, this comes outside, 2 or x to the power n. How do you write? N x to the power n minus 1, right? So this was the formula. Same way here, apply that, 2 into t to the power 2 minus 1. So what is its value? 2t, right? So here what is the value? Let me write it here. So your instantaneous velocity is equal to 0 plus b into 2t. Differentiation of t square is what? 2t, right? So b into 2t, right? Meter per second. So this much is your instantaneous velocity. Whereas here t is equal to time. And now let us find out instantaneous velocity at t is equal to 0. So substitute t value here, b. What is b value? B value is given, that is 2.5, right, into 2 into time is equal to 0. So your instantaneous velocity at t is equal to 0 is 0 only, right? So these many meter per second. 2.5 into, what is 2.5? B value, into 2 into time. Time is 0. Substitute t is equal to 0 in this form, right? So when t is equal to 0, your instantaneous velocity is also 0. Like that, your instantaneous velocity at t is equal to 2 seconds. How much? That is, instantaneous velocity at 2 seconds is equal to b. B value is how much? 2.5 into 2 into time is how much? 2 seconds, right? 2 seconds. So how much do you get? It is 2.5 into 4, right? So 2.5 into 4 is how much? It is 10 meter per second. So 10 meter per second is your answer, right? So this is how you have to do a problem, guys. See, x value they gave. What we have done, by definition our instantaneous velocity is equal to dx by dt, right? So we have differentiated this equation. Okay, so we got this much as instantaneous velocity, and they asked you to calculate instantaneous velocity at time t is equal to 0. So we have substituted value of time here. We got instantaneous velocity at this time t is equal to 0. Similarly, we substituted t is equal to 2 seconds. So we got instantaneous velocity at a time t is equal to 2. When we substituted, we got 10 meter per second as instantaneous velocity at a time t is equal to 2 seconds. So this is how we can use differentiation to calculate instantaneous velocity as well as instantaneous acceleration also. Okay, now let us see one more question that was asked in the previous year competitive examination. See guys, it's a very simple question asked in one of the competitive examination. Okay, so two cars P and Q, they are starting from same point, okay, in a same time, and they are moving in a straight line, and their positions are represented. Position of P is represented by this equation. Position of car Q is represented by this equation. At what time do the cars have same velocity? So they are asking some instant of time. At what instant of time actually the cars have same velocity? Okay, so they are telling at some time the cars have same velocity, right? So from this information I can say at some time, that time only we have to find out. So at some time velocity of car P is equal to velocity of car Q. And let us try to find, so these velocities are instantaneous velocities. Okay, so let me find out. So how do you find instantaneous velocity? Instantaneous velocity of car P is dxp by dt, right, is equal to dxq, right, divided by dt. Okay, xp is given by this equation, xq is given by this equation. You just have to differentiate these equations, right? So let me do it. Differentiation of what is xp? At plus bt square, okay, divided by dt is equal to differentiation of xq. xq is what? Differentiation of ft minus t square, okay, divided by dt. Okay, and you see here, how do you differentiate this? Say this is addition, differentiation of this term plus differentiation of this term. Okay, so here, differentiation of dt, at by dt plus differentiation of bt square by dt you have to do. Okay, so here differentiation of ft by dt minus differentiation of t square by dt. I separated. This is the equation, addition, right? So differentiation of this term plus differentiation of this term. Now differentiation of at. A is a constant, guys. Okay, so a is a constant. So actually this is in the form of uv. So here learn one more rule for differentiation, which I forgot to tell you initially. Initially I explained all the rules, right? Include this rule also, uv rule. There is something called uv rule. If y is equal to uv, I mean when you have a multiplication of two variables, right? So how do you differentiate? It is dy by dx is equal to d of uv by dx you have to do. So differentiation of product is always done like this. Keep the first term constant, u constant. Differentiate second term, dv by dx you do. Plus next v constant and differentiate the first term, du by dx you have to do. So this is the formula you have to apply in this case. This is also in the form of uv. A is u, t is v. Okay, so on applying this formula, what do I do? I'll keep a constant first and differentiation of t, dt by denominator also dt, right? So plus next I'll keep t constant. So differentiation of dA by dt, differentiation of A. So A into dt by dt is 1 plus t into differentiation of any constant is 0, right? So what is your value? It is just A. So you got a value A, right? So differentiation of at by dt is how much? It is A, right? You got it here, A plus. So similarly differentiation of bt square is how much? B, constant outside, B 2 into t, right? So 2bt. So I'll write this way. It is 2bt. Okay, so differentiation of at plus bt square is how much? A plus 2bt is equal to differentiation of ft minus t square. Differentiation of ft is f. Okay, you can apply this formula. UV rule you can apply here. You will get f minus 2t. Differentiation of t square is 2t. Differentiation of x square formula, do you remember? So it is 2t. Okay, so this is what you will get. Now just a matter of rearrangement. I'll just rearrange here. So how I rearrange is f minus a is equal to this a I'm bringing here, this minus 2t I'm taking that side. Okay, so f minus f a I'm bringing here, so f minus a is equal to this minus 2t I'm taking that side. So you will have 2t plus 2bt, right? So f minus a is equal to, here let me take 2t as common. If I take 2t as common, I get 1 plus b, right? So now f minus a by this one I'll shift here. It comes in the denominator. 1 plus b is equal to 2t. So t is equal to how much? So this 2 also, if I shift this side, it will be 1 by 2 f minus a 1 plus b is equal to t. So what is your time? Time is this much. Okay, see in which of the option it will match. Option A is this, option B is this, option C is this. So definitely half into f minus a divided by 1 plus b or b plus 1. So option B is correct answer. Right? See, with the help of differentiation, how we solve the problem, right? So this is how differentiation can be helpful in solving the problems relating to instantaneous velocity and instantaneous acceleration. Not only in these concepts, it can be helpful in the further concepts which come in further chapters. Okay, so this is all about differentiation. Now we will have some basic idea on integration. I already told you integration is just an opposite tool to differentiation, right? So let's understand integration. See guys, as I already mentioned, integration is a mathematical tool that helps to join small pieces into a big piece. We have small pieces. I want to join and make it to a bigger piece. then I can always use this integration. And to understand the concept of integration, let me start with this graph. Imagine I have a graph of y versus x. And suppose this is how I got a graph, a straight line. And if I ask you a question to find area covered under this graph, what do? You would just put one line perpendicular to the x-axis and you will try to find the area of this triangle. Now this is a shape of a triangle. And we know a formula to find area of a triangle, right? Half into base into height. And using that we will find. Fine. And now suppose if you have a graph something like this, right? I got a graph, a line perpendicular to the x-axis. And I asked you to find area covered under this graph. Then what we can do, we just put a line perpendicular to the x-axis and we will try to find this area. So when you find the area of this shape, so this is actually a rectangle, right? So we know to find the area of a rectangle, that is length into breadth. So we measure the breadth this much, so this divided by this difference, right? So this much. We do it and we calculate the area, right? But suppose if your graph is a curve, so we have seen the curved graphs in straight line motion, right? So imagine if your graph is something like this. And I asked you to find area under curve. So this is a curve, area under this curve. How do you find? Say, normally what did you do? You just have drawn a line perpendicular to x-axis. You got some shape. You got either a triangle or rectangle or some shape you had got previously. Using a formula, you found the area. But in this case, how do you find the area of this, this much? So area under this curve to find, it's not a shape, right? And it's not a triangle. It doesn't match with rectangle. It is a curve, but you need to find area under a curve. Then comes integration. We can use integration in this case. So normally, suppose, see, I divide this into this particular strip. Okay, so I'll divide entire, graph into small strips, right? So this is one strip, this is another strip, this is the third strip, this is the fourth strip. Now it is a shape of a rectangle, right? Say, what is this? This is y1, okay, and this difference, let it be delta x, and this is y2. Okay, this difference is delta x. Okay, so this is delta x1, this is delta x2, this is delta x3, this is delta x4, right? And this is my first rectangle, and if I have to find its area, how do I find? I'll find it as, y1 into delta x1. So this is my second rectangle and I will find its area as y2. So length into breadth, right? So this much is length, that is y2 is a length, breadth is delta x, right? And this is my third rectangle and I will find the area as y3 delta x3, right? Fourth rectangle, I will find its area as y4 into delta x4, like this. So the entire region I can divide into small strips and individually I can find the area. And later what I do, if I want the total area, okay, so from A to B, I want the total area from A to B. What I'll do, I can join these things, y1 into x1 plus y2 into x2 plus y3 into x3. Like that I can join the areas of small rectangles and go on. Okay, so sum of so many things. How can we represent? We can represent it as summation. Summation of yn. N can be 1, 2, 3, 4 and so on. Yn into delta xn I can write. Okay, but we can't use summation here. When you have to add so many things, we usually do summation. This symbol we use, right? But we cannot use this symbol. Why? Because you see, here is a curve. Say here, this small areas, this small regions area you are missing out. It's a curve. It's not a definite rectangle. It's not a regular rectangle, right? Somehow this region, this small regions area you are missing it out. So you can't use summation here. Okay. So instead of that, if you want to find area from A to B, this much area, A to B, if you want to find out, instead of summation, we can't use summation because small regions are missing out. They are not counted, right, in our rectangle. So to correct that, we will use a factor called this. This is the symbol for integration. Integration means what? Joining smaller and smaller pieces. Say I broke this entire region into small rectangles. Each rectangle's area I can find and later I can join. I can add all of them. On doing that, I get total area between A and B. Right? So this joining small rectangles, joining of small things, we call it as integration. So instead of summation, we use integrate. We integrate, yn into dx. So why did I put dx? Because it's a small change in x, right? Say I can't use delta also. I have to use dx everywhere. This is dx1 and this is dx2 and this is dx3 and this is dx4, right? So delta means a big change, but it's a very small rectangle. It's a very small change, right? So for small change, we use dx, right? So integration of yn into dx, if you do, when you integrate all of them, you get a correct area under this graph. So from where to where? Limits. So integration from A to B. Okay. So this is how you can show a limit, right? So if you do this, you will get area under curve. So usually whenever you want to find area covered under curve, we always use the mathematical tool called integration. Okay, so if you are, what's the meaning of this? We are joining, we are integrating all the areas from A to B. Okay, from A to B, we are joining all the areas of small rectangles. That is what the meaning of this, right? So this is where we actually use integration. Right? Say finding area under curve is very important. You have seen in motion in straight line, right? Say how do you find the displacement from VT graph? It is by finding area under curve, right? So in many of the concepts, we keep using this integration. So let us learn few formulas that comes under integration. Okay, so with this formula, you can easily solve many problems in physics. So let's understand the basic formulas of integration. See guys, the first basic formula. So this is really very important. Most of the times we use this formula. If y is equal to x to the power of n. So integration of y into dx is equal to, what is the value of y? Integration of x to the power n into dx. Integration of x to the power n into dx is equal to x to the power n plus 1 divided by n plus 1 plus c. This c is called integration constant. So why we have to introduce, when we have to introduce this integration constant? When you don't have any limits here. When you no need to do from where to where you have to integrate. then we use a constant called integration constant. When you have a limits here from where to where exactly if you mention, then we will not use this C, remember. Okay, so this is actually called as indefinite integration. So you don't know from where to where you are integrating. Okay, so indefinite integration. When you do indefinite integration, then integration constant you have to compulsorily mention. Okay, fine. Say for example, this formula I will use. I'll show you. For example, your y is equal to x square. So how do you integrate? Integration of y into dx is equal to integration of x square into dx. Right. So what is the formula? Integration of x to the power of n is equal to x to the power of n plus 1 divided by n plus 1. So x to the power 2 plus 1 divided by 2 plus 1 plus c. That means x to the power 3 divided by 3 plus c. So this is your answer. Okay. So similarly, example number 2. Example number 2. Okay, so if you want to integrate integration of x cube into dx is equal to, if you want to integrate x cube, so how do you do it? You will do x to the power 3 plus 1 divided by 3 plus 1 plus c. Don't forget to put c because it is a indefinite integration. So your answer is x to the power 4 divided by 4 plus c. Okay, so similarly example number 3. So integration of root x into dx. Okay, so this root can be written as x to the power 1 by 2, right, into dx, right. So how do you integrate here? X to the power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus c you have to do. Okay, so this is how we can use this particular formula. And remember, this formula cannot be used when n is equal to minus 1. Okay, so this formula you cannot use. See, integration of x to the power minus 1, okay, into dx. When you have this, usually if you apply this formula, how do you calculate? X to the power minus 1 plus 1. Here minus 1 plus 1, that means 0. Anything to the power 0 is undefined, right? So you cannot use this formula when you have n is equal to minus 1. For all other numbers, you can use this formula. That is integration of x to the power anything is x to the power n is x to the power n plus 1 divided by n plus 1. Okay, so you can observe these examples how we have used this formula, right? So now let's go for formula number 2. If y is equal to 1 by x, okay, so how do you integrate? Integration of y into dx is equal to integration of 1 by x into dx. So integration of 1 by x into dx is always equal to log x, okay, log e to the power x. Okay, so do you remember differentiation of log x was 1 by x. So that's the reason we tell integration is the opposite of differentiation. Okay, so differentiation of this term was equal to 1 by x, whereas integration of 1 by x is log x. Okay, so 1 by x is nothing but what? Integration of x to the power minus 1 into dx. So that means when n value is minus 1, I told you in the previous case, n value should not be minus 1. If n value is minus 1, it is nothing but 1 by x. So integration of 1 by x value is log e to the power x. Okay, so this is really very important. Now third one, what is integration of just dx? Okay, integration of just dx is x. Okay, remember integration of just dx is x. Fine. And the fourth formula, imagine if you have a limits. Now let us start with x plus c. See, this c you shouldn't forget because it is undefined integration. You don't know from where to where you have to integrate. Then in that case, don't forget to put the integration constant. See, now let us do a definite integration, guys. Integration of x square dx. Okay, from the limit 2 to 3. Okay. See, now it is definite. You just apply a normal formula. What is integration of x square dot dx? It is x to the power 2 plus 1 divided by 2 plus 1. Limit 2 to 3. So you will get this x to the power 3 divided by 3 limits 2 to 3. So till here it is common. Now you have to apply this limits. I mean you have to use this limits. See, this is a lower limit and this is a upper limit. Okay, in the place of x substitute 3. Okay, so 3 cube divided by 3. Minus, in the place of x substitute lower limit, that is 2 cube divided by 3. That's it. So what we have done, upper limit substitute in the place of x, right, minus in the place of x substitute lower limit. So what is your answer? It is 3 cube. 3 cube is how much? 27 by 3 minus this is 8 by 3. If you do, you will get the answer. Okay, so whenever you have a limits, this is how you have to do, right? So this is our fourth case that you need to remember. We keep using in various problems. And then coming to a fifth formula, integration of e to the power x into dx. Answer is e to the power x only plus c. Okay, when there is no limits, integration constant, e to the power x plus c. Okay, and now you see sixth case, integration of 5x square into dx. See, some constant is there. So what you have to do, take the constant outside and now you integrate. Integration of x square is what? X cube. 2 plus 1 is 3 divided by 3. Okay, so plus c, right? So whenever you have a constant, when you have a product of constant and your variable, then bring the constant outside, then integrate this with the help of a formula. Plus c, right? So these are the 6 basic formulas or the 6 basic rules you must know as of now. Okay, and there are so many formulas. You have almost around 2 to 3 chapters in class 12 mathematics on integration. You will come across many formulas. You can use trigonometric functions here and everything. It's a very, very vast topic, but this is very, very basic thing that I told you. And as you study the concepts, various concepts in physics, we keep telling you the various formulas of integration. Okay, so when situation demands, we normally teach how to use various integration tools for solving a particular problem in physics, right? So I have just given you a general idea on differentiation and integration and a very basic formulas which we normally keep using in physics. So that's all about today's topic. Hope you had got enough benefit out of this. And in my next video, I will start the chapter 4, that is motion in plane. So to learn motion in plane, learning vectors is very, very important. So in my next video, I will start with vectors, all about vectors, right? So till then, keep learning and take care. See you in the next video.